Hello, flatties and defenders of the spinning globe. It's Critical Think from Down Under, and today, I'm sorry, I just couldn't resist this. It's our videos come out today by a gentleman who I don't dare say his name because I'm sure to mispronounce it, but he's taken the title of the video. It's mentioning, just let me check here, mentioning the Globe cult's unscientific flat earth arguments about horizons, right? And in order to make this argument, of course, he's going to be very scientific and not just accuse globe earthers of being unscientific. He's going to be, of course, very scientific himself, isn't he?
The horizon at our eye level. That is the midway point between the top and the bottom of our field of view when we are looking straight ahead and we have a view as far as we can physically see, which isn't really that far at all.
Which isn't really that far at all? How far is that? Where did you get this measurement from? Is it 2 kilometers? Is it 10 kilometers? Is it 100 kilometers? Is it not that far in comparison to what? What is this? Isn't really that far at all. Where's the science in that? That's just an arbitrary statement plucked out of the air.
But this is where defenders of the globe and anti-flat earthers have to go into outright denial mode. They have to deny that perspective is a thing because of this idea that what we see in front of us is curvature of the globe Earth, rather than it being an optical phenomenon that we know is the law of perspective.
No, you silly boy. We're not denying that there is any such thing as perspective. We're just denying your false interpretation of it. Perspective just means that things get smaller as they go further away. Perspective is not going to cut the bottom off them. Just like this here. You can see there's sand, there's water, there's a boat. And this is what you filmed. So you go down and look. The bottom of the boat can't be seen behind the sand that's, curves in front of you. So is that curvature of the sand or is that perspective that's cutting off the bottom of the boat? And why does it any different? You'll probably accept that as if it's sand, but you won't accept it if it's like a curve in the ocean. And let's look at this. Oh, as the camera goes down, we can't see the boat. Where's the boat gone? Where's the boat gone? Oh, it must be disappeared because of perspective. Oh dear. Oh no, it's not because it's hidden behind a curvature. No. And I'll bring the camera up. Oh, the boat comes back into view. Oh, how did that happen? Magic. Oh, I don't know how that happened. Oh, look at that. As you go higher, you can see more. Oh, how does that happen? Is this some kind of magical perspective thing? I don't know.
But in fact, if you think about how our field of view expands over distance, yet it also contracts due to perspective the further we are seeing, we should in fact see curvature on the horizontal across our field of view from left to right, because what we are actually seeing in the distance is usually part of the surface which is maybe 100 to 300 miles across, yet we cannot see that far in front of us. So we should in fact be seeing some kind of curvature at the horizon on the horizontal, when the claim is of course that we are seeing curvature in front of us.
So here we have an arbitrary set of lines drawn on this picture. Now, there's no science to drawing those lines. This here, 10 feet. Is that right? Well, I'm going to give him 10 feet. All right, let's just say the road's 10 feet wide. This from here to here is 100 feet. which of course it's not. I mean, you can see that it's just a short way outside the road, hardly going to be 10 times 10 feet, which is 100. And then from this distance out here on the horizon to this distance out here on the horizon is claimed to be 200 or 300 miles. And, oh yes, so where is that measurement taken? Can you be a little bit more scientific about that and demonstrate that it's 100 to 200 miles? Oh, no, I don't think so. Of course not. This is about unscientific globe earthers. We're not talking about unscientific flat earthers today. No, but we're going to be totally unscientific here and just draw lines on the screen and hope nobody will notice that I've put no facts and figures in there. Yes, well, maybe all the flat earthers don't care, but there are some of us who do care. And I'll just bring up some pictures of my own in the next slide. So here is a still shot from a video from one of my other movies. It's a fairly wide shot. I don't know that you can get much wider than that unless you use a fisheye lens. And well, we know we can't use one of those. So we can see here that there is an island. I know where this is because I took this. So this is Morton Island, and I'm taking this picture from the top of Mount Cootha. So in terms of how wide that particular horizon is and how far away that is, it's easily calculated. So let's do this calculation and not just pull something out of somewhere. So Morton Island is here, so it's approximately, let's see, 21 miles across. So that's not 100 miles, that's not 200 or even 300. It's like 21. Okay, so that's more like, from a wide shot, that's more like the distance you can get. Most photos are not much wider than that. And now the distance to that island from the observation point is, so the observation point is here. So we measure distance. So it's 30 miles, nearly 31. Let's call it 31. Close enough. So if we look at the map, we look at the photo again. So the forward distance is 31 miles. The side-to-side distance is only 20 miles. So the assertion that you cannot see as far as you can wide doesn't seem to hold water in this case. So, I mean, my word, Mr. Word didn't even actually test it with any measurements, so how do we know what it is in his photo? He's just drawn an arrow on the photo and said 200 to 300 miles. How very scientific of him. Anyway, I've got another shot, and here's what happened. This one zoomed in, obviously, and this here in the misty background, it was a bit of a hazy day. There's the city of Brisbane in the background. So there's the tall buildings that span the city. Now I happen to know the rough locations of those buildings. So in Brisbane here, so there are the tall buildings on this side, and there's another tall building here. So I'm just going to give it a little bit extra, and let's just measure from a little bit wider. Measure here, and we'll go a little bit wider here just in case somebody complains. The CBD is actually bounded there, but I'm just going to go a bit wider. What do we got? 1.24 miles. So 2 kilometers almost exactly. So from here to here is, let's just say it's 2 kilometers. And then you can see, that's another 2 there. That's about 4. And then let's give it another 4 over there. So that's 8 kilometers wide. So it's about 4 times 1.24. That's about 5 or 6 miles. It's 5 miles, and close enough. So now that's how wide that is. Now let's see how far it is. So first I've got to find where I was on the map. So I know where I was. Here we go. From this point here, Mary Cairncross Park. And from Brisbane there, it's 80 kilometres. So you can see in my narrow shot, so that's 80 kilometres as the crow flies. Oh, near enough to 80. It may be just a little bit less because I've gone on an angle there. So I'll just do this again. These buildings. Yes, now I've got to find it again. All that trouble just for a couple of kilometres. 77 kilometres, 48 miles. So across 5 miles, distance forward 48 miles. So again, the across distance is not 200 or 300 miles, and you can see more forward than you can across. So I'm just going to say my scientific measurement doesn't agree with the arbitrary numbers that have been presented on that video. And here's more. So we're also presented with this eye level real horizon because there's mirroring on the surface. And there's a problem here though. It's wrong again. Wrong again. If this is mirroring, what is this piece actually mirroring? There's nothing here to be mirrored. So the horizon is actually drawn in the wrong spot. So really you would have to draw it along here because there's the reflection. This top half is reflected there. This is reflected down there. This is reflected down there. So you can see that I would draw the horizon there. So wrong again. Same here. Yes, that's not the mirroring zone. This reflection has to reflect something. So then I would draw the horizon line somewhere around there. Wrong again. And so here's a ship. And it's sailing away. And here's what becomes of the ship as it goes further away. And That's sorry, that's not perspective. That's the ship sailing over the curve. Simple as that. And yes, the most hilarious part is yet to come. So here's you flatties, you need to study the model that you're trying to debunk. You spend a lot of time trying to debunk something here about, oh, how come you don't see any lateral curve? And you don't actually take the time to study the maths, study the model, so that you're actually informed when you debunk it. So here is the most hilarious part. Now, I'm not going to explain this. You can do your own research on this one. At the end, the actual, what it comes down to is we're not expecting there to be any lateral change in height. Sorry.